Now let's welcome Artur, Igor, Palash, Dan, and Jimmy to the stage.
All right, welcome to Between Two Ferns. I'm super excited to be here. And the reason I'm excited is because this is exactly the panel that I would sign up for if I were an attendee at the conference. Today we'll talk about personalized AI concierges. These are Jarvis-like voice agents that can talk, plan, act, and remember you across sessions. So an example of these voice agent workflows in insurance or in healthcare could be, for example, you call in to verify your health benefits. You might do prior authorization for a procedure that you might want to do. It might help you check for your out-of-pocket costs. It might help you book appointments with your network. And it might follow through all the way till your claims are settled. So with that, by way of introduction, we're going to do something fun. I'm going to ask each of the panelists today to spend about 2 minutes talking about a recent technical challenge that they've been obsessed with at work. Art, I have you so close to me, so I'm going to get you to get started.
Oh boy. I think some of the stuff, I listened to some of the other talks today, and I think one of the things that a lot of people agree that's important is to measure your business outcomes, right? Like all this stuff is like super cool, and it's like really cool to use voice AI, but like in the end, like you're here to solve a specific problem. And I think what people haven't really talked about is like how do you actually do that, and how do you do that at scale? And that's one of the problems that one of the, I would say, problems within voice specifically that we are thinking a lot about at Augment. The piece that's challenging about this is the fact that you can, if you think about calls, you can think about call quality, you can define it under multiple dimensions, right? So you can think about like really kind of core quality issues like, hey, did you hang up on time? Are there a lot of interruptions? Are there latency issues? And then you have other things like that have to be defined on a call-by-call basis, which is going to be like, hey, did I hit milestone 1, milestone 2, milestone 3? And ultimately, I think the hard part is like, how do you incorporate all these factors into a composite score that actually will allow you to figure out like, what is it that I should actually be paying attention to? And so I would say this is like one core problem for us that we're figuring out, and we've having a lot of stabs at this problem, but this is one of the things that we're figuring out. And then I would say the second one is like, when you run calls at scale and you reach a bunch of like corner cases that are quite tricky. And the second thing that we're grappling with is like, what is the right way of testing changes to prompts so that you can get more kind of deterministic, more predictable behavior in your production workflows. So I would say those are the two big ones.
Awesome. Thanks, Art. Dan.
So we sell a AI wearable. It's a personal assistant that captures everything you say. And here, I've been wearing it now for over a year, and the challenge that we struggle with every day is potentially billions of tokens of context to include on every request for each user, not across all our users. And so the question of how do you context engineer to be able to answer the questions people have, both reactively when somebody prompts it to ask a specific needle in the haystack question of a thing they might want to recall from the past with memory, or proactively, trying to actually figure out when you want to proactively tell somebody something that they might want to care about based off the context, like reminding them of something they've committed to verbally. So those are the challenges we wrestle with, is in a world where you've got plenty of context, how do you pick the right context to respond to the AI appropriately and to proactively give people what they want?
Extremely hard challenge. I know a lot of people asking about how to figure out memory, so I'll ask you some follow-up questions afterwards. Igor.
Yeah, so Dan mentioned things that a lot of people wrestle every day with. I'll mention the third one that everyone is facing every day as well, as Inworld is doing orchestration and modeling for conversational AI. And we've launched our first TTS model, public API, back late June. And it is two models, one small and the other one is large. the small one was out of the box real-time ready, so you could just go ahead and use streaming with that, and it would yield 300-400 milliseconds at most to get you the end-to-end synthesis of the voice ready on the client side. But what happened is kind of interesting is that a lot of our customers actually fall in love in using the larger model that was not as fast, being larger, almost like 6 point something times than the smaller one. And me and my team included been not sleeping quite well for a few months trying to figure out how to make the larger model fast. Well, there is infinite amount of challenges. I can talk for hours, but basically it's like, all right, you've got neural net, you've got the compute. How can you feed all these matrices the way that they can be multiplied one on each other as fast as it conceivably, as you conceivably could? And we've been partnering with Modular, who is working on their programming language called Mojo, trying to pilot their advances in creating the super optimized kernels for Blackwell chips. And it's been quite a journey, and I think we're almost there with making a larger model be fast, and I think we've pretty much had the fastest TTS in the market. Yeah.
Awesome. Thank you. Palash?
Hey, I'm Palash. I work at Cloudflare. We recently released like a library called Real-Time Agents, just a library to build voice agents on Cloudflare infrastructure. It's still in beta, but yeah, one of the reasons it's in beta is like we're struggling to find the right API and the right abstractions, because like there's too many knobs to tweak. You don't want to like expose the user with too much complexity. So like, how do you gradually expose them to the complexity? How do you keep opinionated right defaults? At the same time, like there's tens of different use cases. How do you allow all these different kinds of use cases to be like, how do you design the right API so that it's like it fits for every use case?
Thank you. Sounds good. We're going to move on to a little game. And the game is if you have to choose. And I'm going to give you two things to choose. And you can either do it in the context of the healthcare voice agent example that I gave you, or you can do it within the workflows that you do at your companies. So the first, if you have to choose, and this applies for all of you, is you have to choose between dialing realism in your voice agent to the max versus task completion. So realism, I mean how human and how natural it sounds. And by task completion, I just mean the ability for the voice agent to complete the task or its intended goal. So if you have to choose, maybe this time I'll start on the other side. So Palash, if you have to choose between realism and task completion, which one would you do?
Yeah, like in the healthcare context, like if I'm talking to a doctor and I really want to connect to the, the agent on the other side, the human on the other side, and if I need my user to feel that connection, realism matters. But for most voice AI use cases out in the wild right now, the task completion matters. Like I'm calling to reserve a table. I just need to get that done. I don't care like how human the other person sounds.
My turn?
Yeah.
Turn taken doesn't work perfectly. All right, so
Nice.
yeah, so the reality is like there is no black and white. Everything really depends on your use cases. I'm gonna be drifting away a little bit from healthcare, and Inworld started 4 years ago in gaming. And the funny thing with gaming industry in general is that while for most of the industry applications, LLM hallucinations is a bad thing for obvious reasons, in gaming, actually, it might be a pretty cool quirk in feature if the LLM is doing something kind of weird that you would not have expected the, for example, non-playable character to do. So in that regard, realism matters the most. I'm not talking about necessarily LLMs, but like the entire voice-to-voice, text-to-text, text-to-voice, voice-to-text pipelines in general. And in immersion is the term that is usually used in games. It's what really matters, is what like involves people into playing more, which is, in essence, a KPI for gaming companies. While they're designing games, right, they want the immersion to be as high as possible, so playtime can be increased as much as possible. But getting back to the very like everyday life kind of example of table booking, I personally don't care how great the voice is. I just want to book my table, indeed. So, yeah.
Sounds good. So realism most of the time, and then everyone wants to just book that appointment at the restaurant. Dan, let's go with you.
So I'm 100% task completion. So our customers are, we're using technology to augment them with artificial intelligence, not replace them. And so they're busy, they're context switchers, they just want the thing to get done. And if it doesn't sound right, that's actually okay, as long as it gets its job done. So our product in our camp is very much task completion. Obviously, you would love both, but if I had to choose, task completion every day.
Task completion. Art?
Yeah, so we have kind of an interesting, our business is quite interesting. So with Augment, we are focused on the logistics space, and a lot of the conversations that we have are with drivers. And the conversational style is very different. They're very succinct, they're very grumpy. They've had a long day. So, and we try to give them as much sort of like respect as possible. And I think the way we think about it is that, for them, the priority is task completion, just getting it done. What we've seen is that like they will sometimes realize that it's an AI agent and will actually like kind of slow down a bit, even though the model can react much faster, but they're almost kind of learned behavior where they're like, oh, okay, like I am gonna speak very clearly, because obviously they've had some past experiences, even if it's the first time that they've spoken with one of our agents. And ultimately, I think as long as it saves time, then I think everyone's up for it. As long as people can see value, it's all about task completion. The only caveat I would say is I think that if you think about go-to-market and the sales process, I think realism starts to matter a lot more, because if you're talking to the CEO, it's very hard to say, oh, okay, like I'm comparing solution 1 and solution 2, and like it's very hard to be like, hey, like we've developed all the appropriate steps and just the right prompt, and it's going to work super well for you. And because it's hard to do that. Like realistically, you kind of have to bear that out in production and then see how it works. And so the default thing that a lot of, kind of like I would say the buyer is typically looking at is realism. So in some ways, when we think about it, we think about like we need to meet the business objective. That's the only thing that matters. But realism plays a part in the sales process. And so we do have to pay attention to it because of that.
Yeah, so it looks like for most of your use cases, task completion was the most important, and then realism in some cases is needed. The second one, if you have to choose, is perfect memory and perfect turn taking. So for this question, I'm going to focus it on Dan and Igor, since you mentioned some of these. But Art and Palash, feel free to jump in if you also have something you want to add. So if you can dial perfect memory or perfect turn taking, Dan, what would you choose?
I would choose perfect memory, and if it's okay, can I do a live demo that's very high stakes with something that just launched today that will likely not work?
No pressure at all, Dan.
Just to show you what I mean by
Let's do
it. I think perfect memory has the opportunity to deliver some really exceptional experiences. We found that the right context can go a long way. If you have the right context, even with a simple model, you can deliver exceptional experiences. So let me show you an example of that here.
Hey, what's up?
What was that movie? What did Jordan Dearsley say this morning about the movie Her?
Hold on a sec. This morning, Jordan Dearsley pushed back on who will actually bring the movie Her to life. You said you hope to prove Jordan wrong, that it won't be Google, Apple, or OpenAI, the 4 companies you framed for that.
And do you think that Google is going to bring this to life, or do you think Limitless is more likely to bring perfect memory and the movie Her to life?
All right, here's what you said this morning and how Jordan reacted. In the early afternoon, you laid out your stance that bringing the movie Her to life won't be led by Google, Apple, or OpenAI. You said you hope to prove Jordan wrong.
You're a bit biased there. Are you sure that it's going to be Google, or do you think it'll be Limitless if you had to pick?
Totally fair. From today's conversations, you framed it this way around early afternoon.
So you can see an example where, like, this is something that just happened this morning. Obviously, hopefully you all hear the great presentation by Jordan. It's something I hadn't thought would come up today. And these serendipitous moments are the things you might want to remember later is exactly why the pendant is so magical, because it captures things without having to explicitly turn it on. And that's something we've learned is that with the right context, you can do amazing things when you go back in retrospect, especially for creative people who are connecting the dots between lots of things they're consuming. That ability to get perfect memory is really, really magical. So the model doesn't have to be great. The model helps that it's good and it's realistic and it can take turns there. The turn taking actually struggled a little bit, but with the right context, you can do some amazing things.
Totally. You know, I actually forgot which three companies Jordan was talking about, and
Yeah.
I only remember it now that your assistant.
And that's actually really an important part is that most people forget 90% of what happens after a week. It follows what's called the forgetting curve. And so we are just as humans not good at remembering. And what's even crazier is we don't know what we don't know. And I mentioned this to you earlier, when I lost my hearing in my 20s, I got hearing aids. And it was magical, not only because I could hear again, but I remember vividly the first time I turned a faucet on after getting a hearing aid, and I looked at it in awe, being like, this makes sound. I forgot that this makes sound. And by the way, if you don't know that faucets make sound, you should get your hearing checked. But this is the thing that I think AI can help us do, is it helps us augment the capabilities that we have and give us what felt like gaining a superpower. When I got a hearing aid for the first time, it was a superpower. And the same thing is true with perfect memory. You realize so much for your life. Many of you probably forgot this morning what Jordan said, but with the power of AI and augmenting ourselves, we get that capability back.
When I first got my glasses, I had the same feeling. I don't think it was a faucet, but there you go. Igor.
Yeah, so it's complicated, right? Because the memory is such an abstract term, right? You couldn't really separate it out from the knowledge, right? So if we are getting a little bit closer to technical terms, right? So what you've got is that for large language models in particular, you may refer to memory being RAG, right? Retrieval generation, and then you've got the in-context learning, right? It's how much of a single prompt context you can fit into a neural net so that it can comprehend it well. So if I were to choose, well, I would say that perfect memory for me, actually, is more about like the capability of the model to actually comprehend these things the right way is much of a better thing, of course, than perfect turn taking. And at the end of the day, like turn taking and the memory and everything else, humans aren't perfect doing that either. And turn taking can be, like issues with turn taking can be alleviated by heuristics, literally just simple heuristics, right? But memory, if an LLM couldn't really properly find out the information required to generate the proper response somewhere in the middle of the prompt, there's nothing you can do about it. You have to probably find a better LLM. In that regard, the technical complexity of getting sufficient quality for either turn taking or LLM is very different. And I would say, therefore, perfect memory in the context of single prompt zero in-context learning is much more important.
So both of you agree on perfect memory. I love the point that you said about how humans are imperfect with both turn taking and memory, yet our expectations of our voice agents are really, really high. I don't know when that's going to change, but that's something very interesting. Now, we're going to move out from the game, and we're going to focus more on orchestrating and designing voice agents. We love the LLMs in the sense that we can have conversations with them, and they feel very natural. You know, we can chat with them. It's very free-form. There's like a free-form feeling to interacting with LLMs. Yet often in enterprise use cases, you need a certain kind of determinism. You need to take certain steps in a particular sequence. And so my question to you, maybe I'll start with Art, would be how do you balance between this need of free-formness and determinism when you're designing and building voice agents?
Yeah, it's a great question. There's a couple of tools, right? Like you have workflow builders, which allow you to get like sort of like the, you know, pure determinism, right? It's step by step. But it's a very kind of akin to kind of the old IVR systems. It's really unnatural and kind of rigid and just generally doesn't have delight. Then you have like in the Vapi context of like squads where, you know, you take a problem and you break it down and then the conversation's still dynamic, but you lose a pretty heavy amount of determinism along the way. And then you have like maybe one, the one big prompt, right? Which is where you just, have you basically have the LLM do the following the workflow itself, right? Those are kind of the common three models. The way we think about it is that like if something really needs to be deterministic, it should probably be in a tool. And of course, you cannot always guarantee that the tool will be called itself, but models tend to do pretty good at the tool calls, but may not be good at like calling multiple tools or calling them in always the right sequence. And then that kind of like lends itself to like you still have a very kind of organic, natural, delightful conversation while still able to squeeze out determinism out in the areas that actually matter.
That's an interesting idea, basically using your tools or your tools calls to handle part of the determinism. Maybe your server can handle some of those steps in the back end. I want to talk about latency. Everybody talks about latency all the time. I wanted to ask you, Palash, what are your thoughts on latency and how much should we care about this?
The Cloudflare network is on the edge, and we do pitch latency as one of the advantages of building stuff on us. But I feel for like most voice AI application, does not matter as much. Like we're already at like, for most systems, we're at like 800, 900 millisecond end-to-end latency, like shaving further 50, 100 millisecond. Of course, you want to, like for use cases where the conversation needs to be more natural, where so mental health use case, whatever, like that, what we were discussing earlier, sure, some improvement in latency will make the conversation a little bit more natural. But for vast majority, there are other like low-hanging fruits, like back channeling emotions, whatever, to make the conversation feel more natural than latency. And like if you think about it, like a lot of voice AI use cases, either they are like, for example, today they're based on IVR, and they're like switching to like voice AI. So the bar is so low already, like where the conversation, I feel like as long as it gets the job done, yeah.
Awesome. So it matters not as much as people make it sound. And there are other things that could be important. I know we had a discussion backstage about like getting accents or different languages. Those are important parts of making your voice agent sound real and natural.
Yeah, like I come from India, and like a problem that we see is every 100 miles or so, the accent and the language changes a lot. So like, and typical voice models, like, like they'll speak Hindi, but they'll speak a Hindi that the other person will not be able to understand. So those are like far bigger problems than like latency right now in the space.
Igor, I wanted to ask you, you've been doing voice agents or agents in general in gaming. Gaming tends to be massive consumer scale stuff. How do you think, how do you design, or what are the challenges you encounter as you scale these voice agents?
Wow. What a topic it is. Well, so first off, the reality is if it is a AAA game that is about to go to the masses, right, usually what happens is that you don't want to use APIs at all. Like, otherwise you're just going to inquire random cost at random time, which is not going to make your economics to add up at all. So what you're going to do is try to move as much of compute to the edge, right? That's where on-device comes into play, and that's where the complexity gets into your life and couldn't let you out. But the reality is that at the moment, like if you really want to get the quality that brings this immersion to the games with AI, whether it's going to be like an AI companion within the game, whether it's going to be something much more sophisticated than that, and it's not necessarily going to be something anthropomorphic like you've got an NPC or something. AI can be used for different things in the games, but if we take NPCs, what you need to do basically you have to be taking care of speech rec, speech synthesis, decision making, action taking, memory, knowledge, all these things coming together. You couldn't really fit all that into consumer device these days. Not every single person has 4090 in their PC, let alone two 5090s if you were to run a more or less okay-ish single LLM, right? So like at the moment, the tech isn't there yet to actually bring like super high fidelity AI into games, into the masses. But for certain cases where it's okay to call something in the cloud, that's totally fine. And you can just go away with having your thing deployed somewhere in the cloud, and your client is literally just calling that like end-to-end NPC, which is hosted in the cloud. And then everything is all right. But again, the complexity comes into this logistics, literally logistics, because you never know when you launch a game how many players are going to play with that. And being the game publisher, you don't want to all of a sudden tomorrow get a $1 million bill for too much of a usage, right? And that's where the complexity was hitting us at Inworld, is that like, how do we design systems the way that we are ready for sudden spikes in usage, and it's going to be ASR, TTS, LLMs, knowledge, memory, all these things combined. Yet you have to be keeping them real time, otherwise game's going to just not work. Yeah, that's where the challenges are. Like, it's a very complex thing.
This reminds me of the story, I don't know if it is true, where when Amazon had spikes in their their Black Friday shopping days, and the myth is that they started AWS as part of that, building the infrastructure to be able to scale for their own products. That's super interesting. The next question is for you, Dan, and it's going to be about memory. And I want to ask you about how do you design memory? Obviously, there's a lot of limitations and constraints with the models themselves. How do you choose what to remember or how to remember things so that we can do a query like the one you show where you ask, what did Jordan do, or what did Jordan talk about this morning?
Yeah, it starts with recognizing that there needs to be a lot of work that happens before the prompt that actually prepares the data to answer the prompt. So one way to think about it is, if you think about the underlying potential context, you can think about it as like a pyramid where the foundation is data, you've got information, then knowledge, and then wisdom at the top. And if you structure the data the right way, it makes your job much, much easier when you have to fetch the memory. Good example is, the demo I gave, I asked about Jordan. It needs to know who Jordan is to know what he said. He's not saying, my name is Jordan and I think the movie Her is coming to life. That's context that if at capture time you're able to identify a person's voice, you know what their voice sounds like. That's a hard problem already. Speaker diarization and then voice attribution, but then doing that well so that later when you ask about Jordan, you pull out the right piece of information. We structure that data into what we call a life log, which is this hierarchical summary of everything that's said and heard, and it's granular. So you get down to the low-level transcript, all the way up to this whole panel will be just one big card on my life log of each person and a summary of that. And if you have limited context, you choose the level of granularity that you can fit into the context window. So I think it all begins with this question of how do you structure the data up front so that when you need to have a tool that goes in and fetches the data, it's just not dumping the whole transcript of the day, it's picking out exactly the thing you need based off of the context of the prompt.
Do you think that's how we as humans also remember and structure information as we consume it?
It's very likely. I mean, we remember by association. We do remember very poorly. That's the other thing. So maybe following the human model is not the right way to go, given that most people forget 90% of what happens after a week. But yeah, I mean, association is a key part of that. And that's our underlying tool calling mechanism does look at the keywords. It tries to figure out, okay, Jordan, that's a keyword in this prompt. What are all the references to Jordan? People's names are also a big part of what people use to fetch data from their life logs. So we structure the data so that it's easy to fetch that at query time.
That's very cool. Want to ask, so this is for any of you, whoever who wants to answer this one, is when do you predict people will not know that they're talking to an AI?
I kind of feel we're already there. Like, depends on who you ask. Like, because all of the audience right now is, if we work at voice AI, we know like how to spot the difference. But if you for example, take the Facebook AI slop, that's like, old people are being fooled by those. Like, they're already being fooled by the image or the videos that have been generated. And voice is so much more closer to real than those things. So I feel like, if you look outside this building, if you talk to like a general person, they will not be able to tell already.
I think it depends on how long the conversation is. I think that there's so many tells in whether it's like turn taking or whether it's transcription or whether it's like voice synthesis and different like hallucinations in voice synthesis. And so I I think if it's a very brief conversation, like you could hypothetically say like, yeah, maybe like even folks in this room wouldn't be able to tell. But I think if it's a conversation that has some length, I definitely don't, I think we're very, very far. But well, not, I should say, I think we're far. But I do think like if we look at kind of the progression over the past, it's obviously where we look at where the models were a year ago, 2 years ago, and then we extrapolate that progression. I think that we're not too far from getting to the point where we iron out some of the, like some of the warts, so to speak, that are kind of like, are getting us into sort of this uncanny valley, so to speak, of voice of where we are now. So I would give it maybe, like I think 2 years would be kind of like my general estimate on like where we'll be in a place or where it's actually like,
So ranging
like
from
it'll be hard to tell.
almost there to like very soon.
Let's say 2 years,
I'll add that I do think the future's already here. It's just not evenly distributed. We in this room already know what these models can do and have seen the cutting edge. The vast majority of the 8 billion people on this planet have not. So I think people's minds would already be blown by the current state of the art applied to their domain, and they're used to the old school systems where they call and they don't remember you, and they're used to Siri and even getting Google Home to even respond to their wake word. So like the bar is pretty low in terms of what people expect. So I think just the gap between what people expect today and what exists today is already such an opportunity that I agree, maybe it's a year or 2 years before all of us can be fooled, but the vast majority of the world has not seen the magic that exists already.
That's a very interesting distinction. That now that I think about it, when I show voice agents to my mom or my sister, they're like, "Wow, this sounds so human." And when I listen to it, I'm like, nah, it's still not quite there. But I think a lot of people in this room, it's like, it's different. It's just like a different segment of the market who's listened to these. And maybe it's about building all these and showing it to people and blowing their minds. The next thing I want to ask, and this is also for anyone, when you orchestrate your agents, how much of it is like post-call work that you do? Like a lot of the tasks that we ask voice agents to do is either in call or in a session. But some very useful, interesting work happens after a call. Can you talk about how you orchestrate those workflows?
I can have some
Sure,
examples. Yeah, I think, so for us, actually, like majority of what happens is after the call. So to kind of give a model or kind of what this looks like. So let's say that you're trying to figure out where a driver is located, and you might first want to text them and see where they're located. And let's say they don't reply, and then you give them a call because they could be driving and they can't text. And so then you ask for their location, and there's like now transcription around locations in very small cities in the US is very bad. And so you'll get a city, it probably is not going to look like an actual city name. You then have to do a bunch of post-processing to figure out like, what is it? And then, so you'd use Google Mapbox, Google Maps, et cetera. And then you need to really figure out like, okay, like what was the purpose of the call, and did I reach that purpose and the outcome that I was looking for? Now, once that's done, we have an orchestration layer, which will then like take the outcome of the call and then figure out like, okay, is this a good enough update? Do I then send it up into the transportation management system to like the system of record? Or is this a really poor update and I need to then like Slack and message the rep who's the one that would care about the fact that this driver said that, hey, I'm not even close and I don't know where I am. And so a lot of the orchestration happens far, far after the call and not just in the actual voice experience itself.
That's really interesting because I think a lot of people think of the initial voice call as sort of the main agentic work. But actually, in your case, it's kind of like the side character, and then the main character is like post-processing after the call is done.
Right.
Even from like an observability point of view, if you want to like at the end of the call, you could, because in real time, you're running like speech to text to like a streaming model. The word accuracy is not as good as like a larger model that you could like later run and corroborate a lot of things. So you could like analyze everything, run it through like a much more time intensive process, and then like see if your calls are performing as versus if they're not.
Yeah, there's one more interesting use case which I haven't heard covered here is like if you have conversational AI in general that is stateful and you have to preserve certain information between sessions, you can imagine an assistant whom you've been talking yesterday to and you'd like to continue conversation from yesterday. That's where short and long-term memories come into play, right? And you have to take care of that separately. And for the sake of saving compute during the actual inference talking right now, what you usually do is that you accumulate the local memory, short-term memory, throughout the given session at the moment, and then you do some sort and post-processing to synthesize a patch into your long-term memory. You're going to be updating your old memories. You probably have to invalidate certain wrong things that you knew in game in particular. Imagine you have a certain lore within which the NPC is supposed to be acting with, and then the NPC knew some fact, and then you come to NPC and say, you know what, the Earth is flat. But the Earth was round yesterday in the memory of the NPC, right? So what's supposed to happen is that you have to find the right memory, erase it from long-term memory, synthesize a proper, let's say, text representation of that memory for the simplicity's sake, put it in the right place again. And that's what Inworld is dealing with day to day. Like, how do you actually take care of this proper information accumulation and summarization and post-processing? That is pretty tricky, I tell you.
We have a very similar, very different application, but very similar scenario where as you're capturing the audio of everything you say in here, as a side effect, there are things that you might want to remember. So, for example, I'll be making breakfast for my kids and be like, oh, we're out of oatmeal. We now, on a side effect, look at that, and we have a capability that generates automatic reminders, to-do lists, so it adds to my grocery list oatmeal. Now, whether I go buy the oatmeal or not, if I don't verbally say that, that's now state that's out of date, but it's a way for you to sort of, if you had the ability to go back and say if I tell my wife, oh, I went to the store and I got oatmeal, you can now update that record. So that sort of offline processing, I think, is really important to get right in order to actually have useful reminders for people, so you're not just cluttering things you're going to say you're going to do that end up actually getting done without hearing it.
It's awesome. So memory, data validation, post-processing, observability. That's really cool. The next question is for all of you. I would love to hear this from you. I want to hear anything unexpected or surprising that you've learned about during the process of building, deploying these voice agents in production. And anyone who is comfortable to start, feel free to jump in.
Well, one thing that surprised me is that everyone today talks about the models getting smarter and smarter, and AGI is around the corner, and artificial superintelligence is next. The one thing they don't seem to talk as much about is the power of even a simple model today, even an on-device model. The on-device model that are in your smartphones right now, with the right context, can do exceptional things. And that's something that I did not realize until I saw it, that you get the context right, you can get away with much cheaper compute costs, much cheaper battery costs. And that context engineering part is just as important as the underlying models getting smarter and smarter.
Can you illustrate with an example, maybe from your work?
Yeah, I mean, one very common use case for us is sort of the semi-autonomous productivity use case, like drafting an email. So draft an email to one of our investors is Sam Altman. I say draft an email to Sam Altman. Knowing the context of our relationship, the emails we had back and forth, just that alone, even the on-device model, I've tried this with the Apple on-device model, can do an amazing job with the right context. You give it the context you have and the relationship you have, you structure the data right. You don't need AGI to do that for you. I mean, maybe you might need AGI to cure cancer and some new science, but the models that the list today exist with the right context can do really amazing things.
That's really cool. So the future's already here.
Yeah, yeah.
Well, I can take the turn. So one interesting and kind of unexpected thing that happened to us while we were developing a text-to-speech model was that we realized while we were talking to the customers, the first customers and the ones who have already onboarded using TTS in their premises and whatever that is that actually people are totally okay to pay much more for high realism, high quality voice synthesis than they thought it was supposed to be. That's kind of a hot take that we didn't expect to happen, because at the end of the day, what we've realized is that nothing really matters but the quality first. If your speech synthesis model is hallucinating and couldn't pronounce certain things, for example, in the customer support use cases, it's in alphanumerics, right? You have to be pronouncing very complex things and even humans actually suffer from that quite a lot, actually. But like, if the model couldn't cope with that, it's like, it doesn't matter really what the latency is, what the cost is. That was an unexpected thing, I would say, that we've recently realized. It's like, yeah, a good model, it's totally fine for us to pay more for it.
Awesome. So we have surprising power of context with even smaller models, and also basically willingness to pay for great quality speech synthesis models. Is there anything you want to add? 'Cause I have more questions, obviously.
I mean, yeah, I think the only thing I would say is I think that the surprising thing I think for me has been kind of like how like human behavior has adapted to the existence of these technologies. I think in both like the positive and the negative ways, and I think of like the lens that we look at it from is a lot of it is like change management. You go into an organization and someone's like doing this particular phone call every single day, and then we're like, we'll do this particular phone call now. And I think the companies have to like what we've done is we worked with the companies to say like, okay, like how do we actually like the call that we're doing is not a very interesting call, and the person that's doing it doesn't actually want to do it that much. And so like how do we actually like have them focus those individuals on something that's a little bit more interesting. And so I think that like this sort of like change process and transition is, you know, is both like I think hard. I would say hard for companies to like reason about.
Yeah, so it goes both ways. We were trying to change our prompts to adapt to like our callers or our customers, but also the callers might themselves change their behavior, maybe knowing that they're talking to a voice agent. As a closing question, I don't know if we'll have time for the audience, by the way, but as a closing question, for each of you, is there anything, message or advice in terms of building voice agents that you want to leave the audience with?
Quality first. Quality first.
Quality first.
That's right. Build the thing that works and accomplish tasks. Optimize later, not vice versa. It's going to save you time.
This sounds like building a startup.
I've said it before, but context matters. So if I put something, quality is important, but I think it means the quality is the context, getting the right context, and thinking about context before the call, not during the call, and structuring your life so that your life is easier when the call happens, I think is really important.
I think for me, it comes down to like solving the business problem. Sometimes the right way to solve it isn't using voice or not using the cool new tech. Sometimes it is. But I think it just really like, I think in kind of in Silicon Valley and in kind of in this industry, I think we tend to jump on things and like always use them. And I think what we for example found is that obviously we do a lot of voice calls, but we've found that like trying to steer customers away from starting with voice first, because sometimes the voice is just not the right solution, even though it's really kind of like cool and new and attractive. And focused on like what is actually going to drive the right outcome for you, whatever that may be, right? Whatever modality that may be.
Awesome.
I don't have a lot, but yeah, maybe separate out like the voice real-time engineering and like the agentic engineering, like advancements in like the real-time, like vendors will bring out advancements, new models and stuff. Like the core focus should be on like the agentic systems. Yeah.
Okay, so we got quality first, context matters, solve a business problem, and maybe separate the advancements in the real-time part of it versus the agentic part of it. I think we'll have time for maybe one or two questions. I'm really excited about this, and I already see a hand.
Please. So how do you folks differentiate memory from knowledge? Like, what is the definition of memory for you, and what is the definition of knowledge?
So
the reason I'm asking, I just want to give a small background. If I'm building an expert, let's say you are in logistics, like dispatcher or broker, that is supposed to have a very distinct knowledge in that specific domain, and as that person, like digital person, works, it is supposed to develop memory. how do you define like what is what? Where are the boundaries, and how do you manage how do you mix and match both of them to create a great context?
So memory is a hot topic. So the question was difference between memory and knowledge base. How do you manage? How do you design these?
Yeah, I mean, I think to me, I view what you describe as memory as kind of the foundation. It's kind of like the facts, the data, the raw audio, the augmentation of that data to be more useful, to be more information or knowledge. A good example is attributing the voice of what's said by who said it. That piece of information makes it very different. You know, when I say I'm going to go pick up oatmeal, that's a to-do list for me. When somebody who's near me, who's not my voice, says they're going to go pick up oatmeal, that doesn't add to my to-do list. So when you add that augmentation and sort of add that extra metadata to the underlying memory data, that's when it gets useful. For us, you can access it anyway with a tool call. It's just the extra augmentation makes it all that more helpful. And for a lot of the proactive stuff we do, it's important to know. It's a big distinction when somebody else around me says they're going to do something versus when I say something.
Yeah, I think we start with I think memory is kind of what I would consider to be interactive knowledge, right? This is like, I've had a conversation, and then here's the things I've identified that are meaningful in this conversation that I want to retain, right? Now, there's a bunch of other kinds of things that you can do. So like, you have structured knowledge, right? This is like, this could be, think of like, in the logistics space, it'd be like, oh, what is the carrier performance? How many times have they picked this thing up on time, delivered it on time? It could be knowledge that of like, okay, if I have the structured knowledge, how do I then create like interesting views that are super business context relevant and are able to help me answer really kind of complex sort of aggregation style questions, right? And so you can take the memory and then convert that to unstructured knowledge that you can reference for future conversations after post-processing. That also you have the structured knowledge, and then you have the stuff that you build on top of that structured knowledge.
I can see a version of the world where knowledge and knowledge bases and memory end up being the same thing, and it's just more like, what techniques do you use to store it, to structure it, and to retrieve it? At the end of the day, memory is a database, right? And our voice agents need to access some database to store state or to store fact or knowledge. And maybe they just end up merging as the same concept. And today we're still trying to figure this out. Please, can I do one more question? Yeah. Oof. He went first.
Hi. Thanks for all the great answers, very thought-provoking. A few of you have said things like the key takeaways like quality matters and solve real business problems. How close do you think we are to having either standard methods or like good products out there that help real businesses know whether their voice agent or any agent is actually really solving the business problem and doing what it's supposed to do? So we hear people talk about guardrails and measuring these things, but I haven't heard of a lot of solutions that are out there and they're general enough. Do you think this already is out there, or is it coming? I'm wondering what people think about that.
Yeah, I think it's work in progress, right? So what actually happens is that if we kind of step to the very back and think from first principles, what really matters for B2B, right, is that you, at the end of the day, sell a thing that is supposed to improve KPIs of the person or a company whom you sell this thing to. But what are they doing? If they are focusing on, say, serving customers, right, what really matters for them is, abstractly talking, is the happiness of the end user, right? So what really happens, and I'm saying this kind of getting more and more formalized these days, is that basically you have to be having a channel, educational channel, I would call it this way, between you and your customer, and letting them know how to properly build the feedback loop between them and their end user, the way that it is efficient to acquire all of these insights about what actually the end user wants, right? Because it really depends on the use case, right? In gaming, for example, it is the playtime, it is probably immersion, it's for customer support, it's getting stuff done, right? How do you measure that? And every single use case has its own set of metrics. For some, it's one single North Star metric, which is, say, customer satisfaction rate, or for somebody, it's going to be something really complicated. So I think what it comes really down to is building solutions the way that you can let your developers, if we're talking about B2B, easily and reliably embed the feedback loop between them and their end users such that they can get, ideally, automatic insights on how to improve their stuff. I think there is a lot of value in there, and we all know that there's a lot of people and companies thinking about it every single day these days, right? So I hope that we're going to get there soon, and it's going to be standardized more or less in coming years. Yeah, that's how I think about it.
Awesome. Thank you, everyone. Thank you to the panelists.
Yep.
Thank you so much.
Thank you.